What's going on, guys? Reese here from Stoic Pool, and this is the last video in this first validator module with the Aiken course powered by the Cardano Foundation. In this video, we're going to be having a look at the last redeemer case, which is edit. Let's get into it. Okay, so if we have a little look at our validator, the only redeemer case that we haven't accounted for yet is edit, and so that's what we're going to be dealing with now. So we're going to get rid of this true, and instead we're just going to make sure that we change the market datum price and return the asset to the marketplace. Because if we're editing the price of the validator, we need to spend that UTXO. We can't just change it without spending it. So we need to spend it, but we need to spend it back to the marketplace, because otherwise it won't be for sale on the marketplace anymore, right? So we need to do that, and we need to make sure that the price is updated, but we need to check that nothing else changes. So that's basically the scope of works for this video. So what we're going to do is we're going to first expect some own input, and we're going to find our own input for this redeemer from the validator. So we're going to say some own input. We're going to use our trusty list.find, and we're going to attach the inputs this time. And we're going to search the inputs for an input.output reference that matches our oref, which is the argument that's attached to the spend case, if you remember, our spend function for our validator. So what this output reference is it's the output reference of the input we're trying to spend. So if we find an input that matches that output reference, because they're unique, we know that we're looking at that input now. Now, we still might not find it technically, even though obviously if we're doing this, we have to find it. So we need to say expect some own input instead of just let own input. But we just do that and then we handle it. Then we need to get the credential of our validator. So we can say let own hash equal own input dot output dot address dot payment credential. Because if you remember, back to our standard library, if we go to transaction and we look at inputs, inputs have output references, which is where we get our oref from, and then it has an output. So if we need to check the payment credential of an address, we need to say input.output.address. And then, in case you didn't remember from earlier, our address has a payment credential and an optional state credential. Now, again, we only care about the payment credential. We don't really care about the state credential in this case. So that is where our payment hash, that's where our script hash is. So we can check for that because we've got the correct input. We can just extract that straight from our payment credential. And then we have our script hash. Now we can use that. That's essentially the signature of our script. And we can use that payment credential to then find the output that also goes back to our validator. So now we've got our own hash. We can say expect some own output. We can use our trusty list.find, and we can find an output that has an output.address.payment credential that's equal to our own hash. And while we're here, we might as well check the value too. So we say output.value is equal to own input.output.value. Remember, it's own input.output.value because inputs don't have values, they have outputs which have values. I'm going to forget that. So I will forget it because I always forget it. And you probably will at some time too. So don't worry, but just remember, just try and remember. The CLI will tell you that you messed up, okay? And I'm telling you, before the end of this course is over, I will do this because I do it all the time, even though I know like this stuff like the back of my hand. Right, so now we've got an input that's being spent back to our validator. We've checked that that bit is the case, and we've made sure that the value is the same as well. If it's not, this validator will just error straight away. But what we need to do next is make sure that the datum is the same except for the price. So the way we do that is we're going to expect some inline datum with a datum in it, and that's going to equal our own output.datum. So the datum of the output, not the input, the output. We already have the input datum, by the way. Let's see if you can figure out where that is. And then we're going to expect that that new datum is of a type market datum, and that's equal to the datum, the inline datum that we've just extracted from our own output. And now we can check that those credentials stay the same and that the price changes. So underneath that, we're going to say new datum.seller is equal to d.seller, and new datum.price is equal to the price. And that price field is in our redeemer, if you remember. So where we've got medit, we've got a price attached for that redeemer case. So that's what we're checking here. And then we also say, because we only want the seller to be able to do this, then we say that the list.has extra signatories d.seller to make sure that only this will only pass if our seller is signing the transaction, just like we did with dlist. The problem with lots of logic checks sequentially like this, when you're saying this is this, and 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 it ends up being a massive line, like, which is just terrible for programming. So instead, we can use this cool little syntactical quirk of Aiken, which is this and a curly braces, which is basically saying and this, and this, and this, and this, and this. So it checks all of those things return true for the validator to return true. So we're going to do this, and we're going to put it in the curly braces, all these logic checks. And so we can say new datum.seller equals and new datum.price equals price, and it just makes it a lot easier to read. Trust me, if you have a lot of logic checks and it's just a huge line, you have to scroll across that line for ages just to change one little thing if it needs to change, and it's so frustrating. So if you have a lot of logic checks at the end of any bit of validation, always use this little and trick. It's so much nicer to look at. And so that's really important when you're programming. Cool, so now we got that done. We've handled every redeemer case. We can undiscard that output reference because we're using it, and we need to add a couple more imports for our inline datum. Then we can run Aiken check, and you'll see that we have 0 errors and 0 warnings, which is fantastic news. Our validator, our marketplace validator is now complete. We've handled every redeemer case, and so now we can have a look at testing our validator, which is what we're going to be doing in the next module. We're going to do a whole module on testing, exciting stuff, but it's super important for things like smart contracts, where it actually really matters that your validator performs as expected. So we're going to have a look at that in the next module. I'll see you then.